This is an overview of some of the key ideas about expressions in Java. An expression is a combination of operators and operands. You can think of it like a formula that can be evaluated to give you some value. In these examples, the operators are multiplication, less than, and addition. The operands are both numerical values and variables. All expressions have a value and a type. The type of the expression depends on the type of its operands. The type of the expression 5 times 3 is int because 5 and 3 are ints. The value of the expression is 15, which is also an int. The type of the expression total is less than 100 is Boolean. The value will be either true or false depending on the value of total. The type of the expression x plus 1 depends on the type of x. If x is an int, then the expression will also be an int. But if x is a double, then the expression will be a double. In general, if the operands are different types, the type of the expression will be the larger type. So an expression that has an int and a double, or an int and a float, will have the type of double or float. The value of x plus 1 will depend on the current value of x. An expression can be used anywhere that a value of that type is needed. For example, you can pass an expression in as a parameter or return it from a method. Remember that Java is a strongly typed language, so the type of an expression defines what you can do with it. Java has many operators, including several arithmetic operators. The operators for addition, subtraction, multiplication, and division are all binary operators, which means that they take two operands. These operators perform the basic math operations that you would expect. Division, however, acts a little different in Java. When you divide two floating point numbers, you get the answer you would expect. For example, 5 divided by 2.0 is 2.5. But if you divide two integers, the result will also be an integer. Any decimal part of the result is truncated, which means cut off. For example, in the expression 5 divided by 2, both operands are integers, so the result will also be an integer. The 0.5 part is truncated. Not rounded, but truncated, so the value is just 2. If you want to force a floating point division to get the mathematically correct result, including the decimal portion, convert one of the operands to a double or float. You can do this by multiplying by 1.0. You can also do this explicitly by typecasting. Sometimes you can use integer division in a way that can help you accomplish a task, but often it's a bug or error, so always be careful anytime you are dividing. Also, remember that because the right-hand side of an expression is always evaluated first, it's not enough to perform integer division and then store the result in a double. This won't give you the full correct answer. In this example, the right side expression is evaluated to 2, an integer, and at that point, the decimal portion has already been truncated. The integer result of 2 is then stored in the double variable called result as the value of 2.0. So remember that you have to convert one of the right side operands to a double in order to get a floating point result. Another operator is the modulus operator. This operator calculates the remainder, or what is left over after integer division. Modulus is good for determining if a number is even or odd, or if it's divisible by any number. For example, we read this expression as x mod 2. If x mod 2 is 0, that means the number is even, because it can be divided by 2 with nothing left over. Modulus is also good for counting in cycles. For example, let's say you wanted to count in cycles of 3, and you have a count variable that is repeatedly incremented or updated by 1. If you take the modulus each time the variable is updated, you'll be able to count in cycles of 3. First, the value of count is 0. Then it's updated to 1. 1 mod 3 is still 1, so the value is 1. And now let's say we repeat this over and over. So now, count is updated by 1, so it's incremented to 2. 2 mod 3 is 2, so the value is 2. Next, count is updated to 3. Well, 3 mod 3 is 0, so the value of count is now set back to 0. And that cycle repeats. So the value of count will be 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. That cycle will repeat. In a similar way, modulus can be used to make sure that a value is always within a specific range, like the size of an array or list. We'll learn more about that elsewhere. Java has an increment and decrement operator that add and subtract 1 from a variable. These are read as plus plus and minus minus. The expression I plus plus, for example, is equivalent to the expression I equals I plus 1. In this example, I has a value of 0. After we execute I plus plus, I now has a value of 1. If we were to then say I equals I plus 1, I now has the value of 2. These two expressions are equivalent. In this example here, times has the value of 10. After we decrement using times minus minus, it has the value of 9. This would be equivalent as to saying times equals times minus 1, which would then decrement the value to 8. You can create other assignment operators by combining an operator with the equal sign. For example, if value is 5, value times equals 3 is 15, and this is equivalent to value equals value times 3. It's important to understand the precedence of operators, meaning which operators get evaluated first within an expression. For most of the arithmetic operators, the precedence is similar to the rules you learned in math class. Multiplication and division have the same precedence as each other, and they're higher than addition and subtraction, which also have the same precedence as each other. Operators with the same precedence are evaluated left to right. When you aren't sure about the precedence order, you can always look up the Java precedence chart. Parentheses can always be used to force a particular order of execution. Code in parentheses will always happen first. For example, in this first expression, the multiplication is evaluated first because it has a higher precedence, giving a result of 12. The subtraction is then evaluated. In the second example, the parentheses force the subtraction to happen first, giving a result of 16, and then the multiplication is evaluated. When writing code, remember to always strive for readability. So if a line of code might require someone to look up the precedence chart or to have to struggle to figure out the order of operations, there is probably a simpler way to write or break up that line of code. Readability is always better than brevity. This has been an overview of some of the important ideas about Java expressions. Happy coding, Java monsters!